Hi friends, welcome to GMK tutorial. In this video, we will continue our discussion on differential amplifier, but in this case, the input is taken as a common input. Okay, that's why it is also called a common mode case. Okay, that means in the previous case, we are applying the input is a different input values, but in this case, we are applying a common input for both. That means in terms of sign also, same value is applied to the both input 1 at the same time input 2. So for that purpose, let us first draw the differential amplifier. Just in this case, I will discuss with the help of only the MOSFET point of view. Just you will go through the BJT point of view. Okay, the same analysis, but only variations is a little bit variation. So only resistance are maybe varying, right? So please observe always carefully. So this is also representation. Just for analysis point, I will separate these two resistance also. So this is nothing but 2RT, 2RT. So this is also one point. This is also one more point. Okay, one more point of view. Okay. At the same time, this is connected. Both are connected. Therefore, the supply voltage is nothing but obviously VDD. So it is a DC voltage. That's why I will represent by caps. Okay. So this is also same, it is connected to the ground, it is also connected to the ground. So this is nothing but input B in C, that is nothing but input is a common, okay, common mode input, right, like this for analysis for just remembering point of view only. So at the same time I will call the transistor M1 transistor, this transistor is called as a M2 transistor, this is nothing but a drain or D1 drain resistance. This is nothing but second drain resistance RD2. I will call this one as a V01. So I will call this is a V02. So that is a very simple analysis. So for this case, now you have to represent the equivalent model for this one. So in the equivalent model, similar to the previous case, so this part is also equal to, can be considered the same. So this is also like a VB pointer, but in this case you will get a VGS1. So it is also act as a current source. Therefore you can replace with a dependent source, but obviously there is some output resistance, therefore that output is connected to parallel, and obviously RD1 is, so that is a general assumption, right? I think you have some basic idea, right? So I don't want to go through this one. Obviously we are designing so many circuits in case of the small signal model. So the circuit designing for this one, initially some input voltage, so that input voltage I will call as a V in C, common mode, connected to ground. At the same time, there is some voltage difference. This voltage difference is nothing but input voltage, so VGS1, gate to source voltage 1. At the same time, output section, you have a current source device. Therefore, this is nothing but current source device. Obviously, the current source, there is some output resistance is also there. So that resistance I will call as a RDS, R01 output resistance. At the same time, it is also for this drain resistance, there is the output resistance. At the same time, in this section there is opposite. So here first output resistance followed by the constant current source, okay, then followed by the so this is nothing but VGS2. So at the same time input voltage V in C, common mode input only. Okay. So here also some resistance, that resistance is RD2. So small signal analysis, this is nothing but AC ground. AC ground. So for representation point, I will use some separate color for this one. This one, this is nothing but R01, output resistance R02. So this is also constant current source. This is nothing but RD2, RD1, VO2 output, but you will get a V01. At the same time, this value is equal to actually GM2 into the same time the dependent voltage source is nothing but VGS2. Okay, here also same thing, that is nothing but first related to first transistor, therefore GM1 into input voltage VGS1. So that is the representation for this case. But there is another separate part is also there, that is nothing but for tile section. Tile section, it is also having some more two resistance, that is also connected here and connected to ground. So here also same thing, ground. So this resistance is obviously it can be treated as a 2 RT. So this is also equal to 2 RT. 2 RT. Suppose if you are taking the output for this case, this is one more. So the voltages for this case, this one and in this case, both cases, it is equal to the Thevenin's equivalent voltage. That is nothing but similar to first case. Some input voltage. That input voltage is nothing but VNC and followed by the some resistance. This resistance is less than 1 by GM1. So this is the first case. The same time second side there is the same equivalent representation. So this is connected to ground, that is nothing but VNC to VNC. At the same time it is also less than, this resistance is less than 1 by GM2. So these are the two equivalent cases, right? But the main important thing is nothing but now we have to define the values across this one. The voltage in this case is nothing but VO2, I will call VO2, that is equal to, for simplified version, minus, so negative, so it is a negative value actually, minus VNC, so for common representation VNC, RD divided by 2RT. So this is the value. But in this case for V01 point of view, you will get positive value VNC RD by 2RT. So here if you are joining these two values also, no changes in the V01 at the same time V02. So we don't have no changes in the, why? Because both inputs are maybe common inputs. So we don't have any changes in the polarities. So that's why no effect on the corresponding representation. At the same time, one important thing is nothing but, so that is nothing but, so in the common mode case, basically there is a representation for common mode. So common mode VCM is equal to V1 plus VNC plus the second one. So that means it is the average of two voltages or averages of two inputs also. Okay. So V0, so that is not, in case of the common mode voltage, V0 is equal to average of two voltage, therefore that is equal to common mode, VOC is nothing but common mode output voltage, that is nothing but average of those two. So in this case, what we are getting is nothing but V01 is nothing but obviously V01. Obviously we are getting, in both cases we are getting a negative value, right? So why? Because same signals are, so it is also negative value. So no polarity variation. So both cases the polarity may be same. So that's why in both cases we are getting a negative value. Therefore minus V01 is nothing but minus VNC common input voltage RD2 by 2RT. Okay, plus VNC2. So VNC2 is nothing but, that is also negative value, therefore minus VNC into RD by 2RT. 2RT, actually not RD, it is a 2RT. 2RT by 2. So both cases, both values are same. Therefore average of that value is equal to get cancelled. Therefore you will get only in terms of Vin is a common value. Therefore if you want to find out the gain for this one, common mode gain is equal to output VOC by, here input is a common in both cases. Therefore you will take left side, VNC common mode input is equal to, what is the remaining left out term? That is nothing but RD by minus RD by 2RT. So this is a common mode gain in case of the MOSFET. Suppose if you go for the transistor point of this common mode gain is the only variation. RD is replaced with the RC by 2RT. So that is the only variation, right? I think it is very clear, guys, in case of the common mode, in case of the differential amplifier with the help of a MOSFET. I hope it is clear. Okay, thank you guys. Thank you for supporting. So thank you.